everyone, welcome to you in the live stream. Hi there. I did promise yesterday and I did deliver. I have coffee with me this time, which means it's gonna be energetic, productive Make It stream. Hello everyone and welcome. And today, there is a fair bit of work to be done actually, as always. So, let me actually list all that I need to do today. Because the title of the stream is, if I'm not mistaken, Quaternions and Simulating Binary Numbers, right? That's because today the two main things I want to do are... Why do I not have the documents open? Come on. There we go, and there we go. The two main things I would like to do today are, in order, the research the Quaternions, for which I have picked 3 different sources that we could use. There we go. 3 little paper thingies for Quaternions, and script some more data and also simulate it. Switch to live chat. There we go. Thank you for reminding me. I did switch now. Those are the main things I would like to do today. We'll see how it goes. We'll see. Because with the animations, I have been slowly moving forward. What's happening to my mouse? Hold on, something is off. There we go. Now it's better. And so and such and what. Yeah. Yeah, so I guess that's it. Let's get to work. How is everyone doing? Hi, the Stamp. Hi, hi, Masha. I download. Hi, Baya. Hi, welcome. How you all doing? Let me just have another sip. Yum, yum, yum. Coffee, my beloved. By the way, I woke up Make It stream. Well, that's perfect. That's perfect then. I still have Cookie Click open in the background because I'm not addicted. You're addicted. I guess what we should start... That's a good question. What should we start with? Because there are other things I want to do as well. Work on the Electricity for Electronics video, because of course. Another thing, work on the website a bit. That's another thing I would like to do. So what should we begin with? Hi everyone, what should we begin with? Researching Quaternions, simulating-ish, you'll see. Simulating things for the binary video, binary numbers. Right here is where I want to represent binary numbers in a way that would require me to kind of simulate them. Or maybe work on the Electricity for Electronics video, maybe work on the website. What should we do first? I'm open to suggestions. Poll. Fine, we're doing a poll. What are we starting with? Let's do binary. Well, we'll leave that up to a poll. Let's do... Simulate binary formats. Or maybe animate the electricity video. And last, work the website. There we go. We're doing a democracy, everyone. We're doing a democracy. Hold on, I need to get myself a pillow for my back support. Because I can already feel it. Hurting. There we go. Ah, back support pillow. My beloved. There we go. Okay. So. Democracy. Democration. Oh, shit, is there a no word for voting that ends with Sean? Liberation, close enough. Research Quaternions is winning. Well, color me surprised. We're gonna do it the brain rot way, because of course we will. I feel like this would be a good start for a paper. This is from UMD EDU, and it is quite chunky, with the downsides of Quaternions at the end. Lovely. Election! Thank you, Tha. Thank you. Thank you. Tha, you get the golden star. What's poppin'? I did ninja, hi. Not much. Just, you know, the usual. There we go. I like it because it's behind me and I'm a clown. It fits. So, how many pages? 38. Not too bad. That's manageable, I think. Quaternions. Let's get through it. Quaternions is essentially the extension of complex numbers. Rather than introducing just one value whose square is -1, we introduced 3. So we have 3 values whose square is -1. And then we also get this. I like the plus there, jeez. Moreover, we insist that these are different from one another, and we relate them as follows. ij is equal to k, jk is equal to I, ki is equal to j. So they are going in cycles about this, right? ijk, jki, kij, yeah, okay. They are going in cycles about this. And from these rules, we can get some other facts. Let's double check that, because I feel like this will not be an easy thing. Hold on, I'm running out of space here. There we go. Fixed. Alright, alright. Oh yeah, you won't be able to see this behind me. Damn it, I got these backwards. This is such a mess to navigate. Alright, perfect. Perfection. Perfection! Hi Mega, I love you. You're the best content creator like ever. Oh, thank you, Swim. That's so kind. Thank you. I'm glad you like my content. There we go. Now, we have I squared is equal to j squared is equal to k squared is equal to -1. Moreover, we insist that this is different from one another and we relate them like so. Okay, so we have, basically we have I, j, k. They all have a hat on. So maybe I should do it with a hat. K. And they kind of loop together. Do you think America is gonna Great Depression again? I don't feel comfortable stating anything economics related publicly, considering my limited knowledge on the topic. However, if I was a betting man, which I'm not, right? If I were a wager, which I would never, that's way too risky for me, then I would say probably yes. Like, the threat of recession has been pretty public for a really long time. What's more, the biggest issue in American economics, in my personal opinion, is the fact that in many different unrelated portions of the economy, it's been focused on short-term development. And in that case, what I mean is that anything from urban development up to certain regulations and so on and so forth. Basically, a lot of portions of the American economy are really centered on this short-term kind of way of thinking. So anything from suburban development, you know, where basically you have large portions of different cities which are zoned exclusively for residential single-family houses, which actually lose money for the city, which means they are subsidized for the city. They are extremely unsustainable. Through, I don't know, BlackRock and Blackstone, you know, they are famous cartoon villains recently, but the problem they have is that they might actually not have all the resources they claim to have, simply because they are not really forced to sell off their properties to reevaluate how much they're actually worth, and it just keeps going, so on and so forth. So, for example, there is basically a lot of different aspects of the economy which work this way, which work great short term, terribly long term, and the reason, and in my opinion, the much more interesting thing is that if one domino starts to fall, then all the others will soon follow. So if this is a huge economic crisis, which will then cause all of the others' short-term policies to start the fire, that will be probably the recession. But that would be my guess. As I mentioned, I'm not a betting man. Don't listen to me. I'm just a silly YouTuber who does videos about silly stuff, so don't listen to me. Right, what do we have? These now. So so basically we have ij is equal to k with a plus. That's important. There we go. That would just be my. I don't know. I'm European. What would I know about American economics? For these rules, we can get some facts. Ji. Okay, so if we swap these around... Oh, that's tricky. Okay, so if we swap them around, we get... ijk, jki, kij. That makes sense. So basically, we can imagine it on like a circle with k, j, I, where it is going k this way, we're getting a -1, and this way, we're getting a +1. That's how we can imagine it. So multiplication to the right gives us a -1. Multiplication to the left gives us a +1. Kij. All right. The opposite of a vector cross product. I don't know. I don't see a way in which it's like a cross product. I mean, it is multiplication, so in that way it's a product, I suppose. I don't know. So we have this. From these rules, we get other facts. Ji is equal to -k. Yeah, I'm gonna trust all of these because, like, from this we could just, you know, get all of the properties. Not really interested. For example, ij is equal to k, yeah, there we go, cool. At this point, notice that, for example, ij is equal to -ji, so multiplication as defined is not commutative when it includes, yeah, so that's the important portion of quaternions that everyone knows about, the fact that they do indeed go backwards with multiplication. Sweet, lovely, fantastic. No, I've been given what I currently suspect a current sample with the main scent being cinnamon. Oh, that's nice. That's nice. Hope you like it then. Where have you gotten this sample from? What topics are we on exactly? Quaternions. They are like complex numbers for complex numbers, basically. Or like real numbers for complex numbers for octonions. Make it make sense. As we'll see soon, it's not anti-commutative either when you go full on with quaternions. Using variation label proof show that kj is equal to -I. Okay, so ki is equal to j. There we go. Now ij is equal to k. And so ji is equal to -k. Can I say that? Can I say this? I think I can say this, but I'm not completely certain. Oh yeah, because the backwards, right? Because the backwards thing. Yeah, okay. So we can say that this opposite would be negative, which means this would be negative, and as such we would have negative here. Jesus, is a mess. Oh yeah, you briefly mentioned in your additional quantum video. Did I mention quaternions there? It's a really old video. I mean, makes sense. I've been planning to make a quaternions video for quite some time now. What do I, J, K represent in 3D space? Nothing. They don't represent anything. They're numbers. That's kind of like asking what I represents in a 3D space. Well, nothing. It's a field. At least, actually, no. I think this is a ring. Actually, yeah, because the because the modification is not commutative, right? So it's not actually a field. It's a ring. Which means from this you can make a 3D space if you want. I imagine it would look like this. I think this would be your 3D space using octonions. No, wait, that's octonions. I'm an idiot. Quaternions. Jeez, get it together. Quaternions. This would be a 3D space using quaternions. But IJK, you would have a different IJ and a K for each dimension. Right. Negative K, therefore JI. Right here we would have -1, negative K. This is so annoying when you have to be careful which way you multiply. But I think I can say that. I don't... Jeez, what can I say? Make it, what are you gonna do for 800 days? Similar thing that we've done for 750. Which is, I think I'm gonna play Doom Eternal, where for every death I donate either 50 cents to charity or $1 charity. I don't know how many times I'm gonna die. That's what I'm asking, which axis, which number. Mashrit, I don't quite understand your question. I'm gonna get psychologically evaluated tomorrow. Hell yeah! Are you mouse fighting patrons? Get him a stylus pad. I used to have a stylus pad, but it just broke. Actually, well, not a stylus pad. I had a... It was a cheap thing. $0. Tempting, I wish. I'm sorry, Swim. I'm sorry, Swim. Patrons can't get me a stylus pad because I'm funneling all of the patron money to play Doom Eternal for charity. That's where my monthly expenses go to. I'm like a gambler, except I don't gamble. I just spend it on charity money. KJ. Okay, so we have this. Backwards means backwards. Or we could do the same thing here, which we can't divide both sides by j, can we? Because it's not commutative, which makes it so difficult to do anything. Alright, k is equal to negative j. That's what we know. Now, can I bring the k onto the other side? Well, no, because if I bring the k on the other side, would I put it to the left or to the right? This is so awful. Study the organic chemistry of cancer and fix it yourself. Surprisingly difficult. Okay, so we have this. Using this, we're trying to show that kj is equal to negative I. Make it yourself. It's sick. Okay. Now, kj is equal to j, ij is equal to k. Kj is equal... I'm an idiot. Wait, what? Ki is equal to j. Ij is equal to k. Shouldn't kj be equal to I? No, ki is equal to... Right. Jk... Jeez, this is terrible. I hate this. I love it at the same time. Yeah, because okay, so just this. Jk is equal to I, and therefore kj is equal to negative I. Okay, I was overthinking it for absolutely no reason whatsoever. You can define using quaternion. A quaternion is an expression of the form Q is equal to S plus AI plus BJ plus CK. Makes sense. Kind of like complex numbers. Makes sense. We extend addition, subtraction, multiplication to the quaternions by obeying the above rules. So the distributivity and associativity. Okay. This of quaternion is denoted H. Why is it denoted H? Why? Why would it be H? Why would it be H? Why not a Q? I am fine. Whatever. Yeah, I don't care. I don't care. Why would I care? Right. Okay. For Rowan Hamilton. I hate this, but whatever. If Q1 is equal to 2 plus I, and Q2 is equal to 3 plus 4J, then them multiplied together works like this. Makes sense. Okay. Okay. H for help. And just to compare, if you do it backwards, then they flip. Okay. So far I'm with them. And then more calculations, right? It's worth doing one or two of these, just to settle the rules in your head. I'd really rather not, honestly. I'm just trying to make a simple video. The real or scalar part of Q, denoted like this, is equal to S. Okay, the imaginary or vector part is all the other ones. Makes sense. Quaternion scalar part equal to 0, that's a pure quaternion, okay. Scalar is vector part equal to 0. Pure quaternion and 7 is a scalar. Wait, why is 7 a scalar? I'm sorry, what? Oh, this, never mind. For a second I thought they were going for single one. Okay, yeah, that messed me up. Because right here was a 2, right here was a... Okay, so this number is a quaternion, this number is a pure quaternion, this number is a scalar. That checks out. So far, I'm with them. Might get anti-silly pills. Oh no, not the anti-silly pills. Okay. Quaternion properties. They're non-commutative, right. Not really a theorem. Oh, this is the screenshot I shared, by the way, on Discord. Observe that, see examples above, in general, Q1 times Q2 is not equal to Q2 times Q1. So quaternion multiplication is neither commutative nor anti-commutative. This is not really a theorem, I just called it one so it would have an impact. There are some special cases, as we will notice later. Yeah. To use of the notation I, J, and K are not arbitrary, we can use vector operations like cross products and dot products on the vector part. Well, there we go. That should answer your question, Mashrit. We can use vector operation like cross product and dot product on the vector part. I hope that answers your question. If Q1 is equal to this and Q2 is equal to that, then Q1 times Q2 is equal to this, Q1 times Q2 is equal to this. Both quaternions, the first is scalar and the second one is pure. Alright, okay, makes sense. So cross and dot give you the vector and the scalar. Alright. Cross and dot simplified quaternions multiplication is quite a... in fact, the cross and dot simplified multiplication quite a bit, as I'm showing the following. Right, makes sense. What do I play? Hollow Knight or Terraria? Silk Song, that's what we should play, obviously. I've never played Hollow Knight, nor have I consumed any content. Make it and these 40 vectors and 4 elements. If so, then how can you have a cross product? Couple of things there. First of all, is cross product limited to 3 dimensions? I don't know. I don't do any applied linear algebra, okay? I do only the nonsensical linear algebra. I do the nonsensical part, not the applied part, so I wouldn't know. But you have it separated into the scalar and the vector, so you're only operating on the v, not the s. Each time we just do a dot product, okay. Mm-hmm. Hmm. I stopped playing War Thunder to watch this stream. Why? Then my science teacher told me that light is massless because it's made of photons. Why are photons massless? They come to reply because photons are made of quarks. They did not say that. I refuse to believe that they said that. They're massless because they don't couple with the Higgs field. Everyone knows this. That's common knowledge. I'm sorry, one of my friends is a theoretical physicist, and I'm not well because of that fact. Why? The internal paint I felt, that's wild actually. Did they genuinely meant it? Mine said that helium had 8 valence electrons. Damn. I am... I don't know what to say to that. That's just really rough. Signal flows from the first, and from the relativity of the dot product, and the relativity of cross product. The second line isn't really necessary, it's there to make the obvious how the community fails. The cross product part complicates the situation. Okay. Okay. I'm not gonna go over that. Although it could be required, damn it. P equals mv, k is equal mv squared, e is equal to mc cubed. So for me, you got it wrong on the test because they believed him and not me. Jeez. That's terrible. That is truly terrible. How can... Wait, science teachers? But how can you, as a science teacher... First of all, think that helium has 8 electrons. And second of all, think that... like, photons are made out of quarks! They're elementary particles, for goodness sake! Also, I mean... Okay, Flame... I swear... Flame is about to join the stream and tell me, actually, I made some helium with 8 electrons in the past. In my add 6 electrons to an atom machine. Slightly above high school level knowledge. But, come on! Helium having 2 electrons is not high school level knowledge, is it? At least I think so. At least I think it's below that. Also, knowing what photons are, but not knowing that they're an elementary particle is mind-boggling. That's kind of like knowing that gravity is not a force, but not knowing that it's a fundamental interaction. Why do oranges taste like oranges? Because oranges are made of apples. That is actually a spot-on analogy, Swim. That is really the kind of response. the actual answer, if you're curious, is because funny enough, the way I got this answer to the question of why are photons massless isn't because I asked that question, only because I've been working on an elementary particles video, and I delved a bit too deep, and Remco just mid-explanation was explaining to me the Higgs field, and all of a sudden was like, oh yeah, by the way, that's why photons don't have mass. Just like that. And so it was just... It's not a simple thing, but I mean, the answer is simple. I don't understand how it works. I'm not gonna pretend it. All I know about this is that E equals mc squared. In order for something to have mass, it needs to have some energy, which doesn't really make sense for most particles. Therefore, we have the Higgs field, which gives them energy no matter what for them to have the mass, and photons just don't couple with that field, therefore they don't have mass. But that's all I know. They only have kinetic. What are these features? That's what I like to know. Alright, note that for Q we have real is equal to real backwards, imaginary isn't equal to imaginary backwards. Makes sense, right? And the commutative is only for the vector part. Do the brute force calculations for the above theorem. Above theorem to use the... Wait, what? This one? With the cross and dots? I'd rather not. I would really rather not. I don't like the cross and dot products. I don't like them. I really don't like them. Anyways, that's why we call it light instead of heavy. Exactly, that's why photons are light particles and not heavy particles. Stay in school, kids. Can I just do the brute force calculations by hand? Okay, prove that Q1, this... FV... Wait, what is that symbol? That's not equivalent. Equivalent is 3 line sideways. Anyone knows what this symbol is? Or what it's supposed to be? Oh, I can't zoom on this. That's phenomenal. This right here. Oh, and that's parallel, because treating as a vector? I have no idea. I'm acting as if I would know. Parallel. That would be my guess. Because we treat it as a vector, right? That doesn't make sense. That doesn't make sense, actually. I don't think to tell interaction deficient people that we have a theory can explain the interaction of the whole entire universe except gravity. Yeah, my beloved, quantum field theory. Quantum field theory, my beloved. I hold it dear at heart because electromagnetism is objectively the best fundamental interaction. You heard me. You heard me, you liberal snowflakes. Yeah, electromagnetism is the best. I'm not afraid to say it. And no one cares about gravity anyway. It's on the tip of my tongue, that's what she said. Okay. Pure Quaternions, we have this, right? Wait, for pure Quaternions? Aren't pure Quaternions the ones that don't have, like, what would be the difference here? Oh, because they're on the inside. I am such a moron. Wait, no. What? That's in general. Aren't pure quaternions just a subset of the in general case? My comedy is unparalleled. Calculate the product cross product. Yeah. Isn't that the dot and cross product should be computed this way, but it's good to keep in mind they can be. The conjugate of a quaternion is denoted Q and defined by minus. Okay, so everything switched to a minus, that makes sense. I have been wondering, what will be the conjugate of a quaternion? This makes sense. We don't write Q, since Q already involves a vector, and this could cause confusion. A better way to write this might be this. Okay, checks out. So we treat the V as a vector, which begs the question, are complex numbers the same thing except the vector is one-dimensional? To which it appears yes so far. Makes sense. Proof brute force. Okay, so the first one multiplied by the second one is equal to backwards. Okay, so basically, let's do it on a single one because I feel like the intuition is there, but I want to double check it. So for example, I know I, K, this. I'm glad that we're back to complex conjugate being a star because the bar always confused me. I've been introduced to complex conjugate of a star. Kij. Wait, no, not Ik. The order, jeez. Kij leads to Ki to J. Okay. So Ki is equal to J. Right? Complex conjugate this, we get a minus. Because J, so a minus. Yes. There we go. Now, complex conjugate, now we have Ki. Complex conjugate of them would be a minus minus. This is multiplication, by the way, don't mind this. Is equal to what? Well, it would be minuses cancel out, right? This is awful. I hate this. Negative K, negative I. Negative K is going back to the drawing boards. This going backwards, which means I times J is equal to K, J times I. So it's Ji times negative I. Jk is I, Kj. Kj is equal to what? Okay. I was once studying relativity and how everything moves at sea. My brother walks in and says, "Isn't it obvious if my hand didn't move at the speed of light, I couldn't see it?" This is how Einstein... Honestly, these physicists feel so smug after saying that light travels at the speed of light. I feel like I've done more of a mess than to help with anything here. Jikj. I could get Ik together. I need this cheat sheet, honestly. IJK. That's the order. Okay, that's the positive order. IJK. IJK. IJKI, which means this one would be negative J. K. Ki is equal to J, which means this would be negative J. So this would be J negative J. J. think the answer is I don't. IDK. Swim. I would just like you to know I am stealing that joke, and I am going to put it in the video. I just want you to know that. IJK. Okay, no, we're closer now because I squared. I can't take the minus out, can I? That would be too fucking easy and convenient. What is a quaternion multiplied by a negative self? Hi, the revamp. Hi. What is a quaternion multiplied by a negative self? Do we have that in the paper somewhere? Oh, that is the way it's normally done. Good, that's great. Wait, this, we can package this, can't we? I'm an idiot. Once you have 3 quaternions. J times j equals -1. Yeah, but what about negative j times j? That changes the story. IKJ, we can package this. Because... that's because... Kij is -1. Kij is equal to -1. Right. Put the j right here. JKI. JKI is -1. Which means IKJ is +1. Which means this would be... That doesn't feel right. Yeah, you misspelled the I, by the way. Yesterday asked IU. You should reference me after making that joke. Alright, Swim. I'm doing it, by the way. I don't know. I'm gonna... Absolutely no context in the script right now. Swim. IJK is equal to -1. But IKJ, that should be just 1, correct? Or am I crazy? Because then that would be J1, which would be J, tracks both. Which is a problem, because this would be then J, which can't be. No! Hold on. Hold on now. Hold on. Let's talk about this. I did something wrong. You forgot to swap them. What do you mean? Ki is equal to IK. What do you mean? This right here, I did Ki, that's a J. This is what I did. On the next step, well, there is no next step. That unless you mean the second equation, this. Okay, so we have 2 equations here, which is Ki complex conjugate and K complex conjugate I complex conjugate, and in the top one we have this equal to J complex conjugate, which is equal to -J. And on the bottom, we have K, which is equal to K complex conjugate, which is -K, -I, which is equal to... This cheat sheet. This is... Oh, help me someone, please, with cheat sheet. Hi, the Bessic. Hi, welcome. How you doing? Why am I awake? Oh, no, I'm good. ijk k, okay, ijk negative 1, ijk negative 1. So ijk negative 1, which means ij is k, so ji, and then ijk, jk is I, means kj is negative I, which is, this is equal to j1, this is just j. K is equal to negative I, negative kk. Why though? What? What do you mean? You mean to tell me that this isn't true? Like, what is the order of operations there? Is complex conjugate coming before multiplication? How do you interact with kj? Well, apparently the complex conjugate just... where is it? Where is it? Hold on. I had it right here. There we go. Like, complex conjugate just swaps them to negative. Look at the theorem. What theorem? I'm not going with any theorem, I'm just going with this. You wrote ki conjugate is equal to j. Yes, I did. This is true. And why is it not true? Next, you wrote ki whose conjugate is equal to negative k negative I. No, what? Mashrit. It inverts, not makes negative. No, yeah, I mean, yes, correct there. Everything non-real negative, yes, it inverts, not makes negative, that's true. But still, I don't get this. What am I doing wrong? Oh, because I'm doing this backwards. Yeah, so this should be negative j. Yeah, right, okay, that makes sense. Because then we would right here have kjji. Wait, no, this right there, kjji, there we go, that's what we would have. kjji, this gives us a negative 1, but I don't think that's the easiest. Well, I mean, no, we have to do it this way then. kjji gives us k negative 1I. It feels dumb. I'm not doing any addition or subtraction here. I don't know, I just don't want to write it with brackets everywhere. K negative 1I, which fingers crossed that I can just say k negative I, because otherwise, fuck me. K negative I. How do I get rid of the minus in the middle? if I have a minus on the second thing, what does that mean? Multiplication non-commutative, yes, that's the fun thing about Quaternions. Octonions remove another thing, but I don't remember what it was. How do I remove a minus in the middle? If I have k times negative I, what is this? What is that equal to? Alright, it's fine. I can figure this out. This is Kij. K negative ij. Negative Kij? Well, I mean, that would make sense, Marshred. But can I do that, though? That's the problem. Can I do that? I mean, negative I, that would be... Hold on, no. Oh, I have an idea. Because negative Kij... Okay, Kij... So, jk is equal to I. Therefore, kj is equal to negative I. Oh, I fucking done it. Kkj, this one is just negative 1, gives us negative j. This will be fun. This will be fun in the video. This will be a lot of fun. Holy crap. Oh my. Oh goody, oh great, or good, or golly. Oh. Just raise it to the power of 4, then you make regular numbers. Genius. Okay. Oh. Proven with an F. Okay, magnitude and norm of Quaternions goes this way, which I'm just not gonna question. This just checks out. I'm just gonna quick look and just like in complex, yeah, exactly. Right, yeah, flipped. Cool, neat. Honestly, if I see proof brute force one more time, I'm gonna lose it. Just leave it as an exercise for the reader. What kind of proof? It follows that this... Okay, so we can get the norm now. Neat. Square root of it multiplied by itself, the complex conjugate. Elaborate the above proof exercise. I'm not doing those exercises. I'm just but a simple YouTuber trying to make a video. A simple, easy, simple math video with nothing special there. The norm is multiplicative. That is for Q1, Q2. We have this. Alright, makes sense that for the norm you can split it in 2. Kind of makes sense. Does it make sense? Yeah, I think so. What's more, I'm pretty certain... Wait, norm is a real number, correct? Which means we could do it backwards. There we go. Yeah, you could do it backwards. Oh, it feels so good when I think of something and it just works properly. Yeah, we can do it backwards of the norm. The same is true in C, okay. A unit quaternion is a quaternion with norm 1. Makes sense. Note that for unit quaternion we have is equal to 1, right? Unit quaternions are interesting in the sense that they are all square roots of negative 1. And all square roots of negative 1 are unit quaternions. So by contracting h, by introducing 3 new square roots of negative 1, we actually have gained infinitely many. Alright. Okay. Okay. Q is a unit pure quaternion if q squared is equal to negative 1. Checks out. Alright, I'm with you so far. For a genuine quaternion, right, we have q squared is equal to scalars multiplied together minus the dot product of the vector part, scalar, vector, and the cross. I'm not too interested in thinking of them as vectors. I know it's important, but That feels like too much work, honestly. I'm already swamped. Maybe in the future. We cannot have s equal to 0 since we will apply that a is equal to b is equal to c is equal to 0. Right. Wait, what? Q is equal to -1. Then we have 2as be equal to 0, 2bs equal to 0, 2cs equal to 0. Pardon? Okay, yeah, s has to be equal to 0. That makes sense. Alright. So all of them are square root -1 but not to each other? Yes. They are all ms. Consider what this states. If we think of unit pure quaternions as unit vectors, which they are, then they form the sphere of radius 1 and at the origin. So in H, there are a sphere's worth of square root of -1. This paper has banger quotes. I absolutely love these. A sphere's worth of square root of -1. Actually, hold on. I need to screenshot this. This is funny. I swear. Nothing like. A sphere's worth. It turns out that this is where we start to see more similarities to complex numbers. In complex in C, unit complex numbers correspond to rotations in 2D, and there's a circle's worth of rotations, 1 per angle. In H, a rotation has an axis of rotation, and each of axes can be represented by a vector. So it turns out that each unit pure quaternion corresponds to an axis of rotation. We'll need to go a little further in order to bring the angle of rotation into the picture, but that will happen in the next section. Okay. Oh, that's we're in pretty deep. We are in pretty deep. A quaternion Q is invertible if there is another quaternion known to Q minus 1, such as Q minus 1 is equal to Q minus 1 is equal to Q, times Q is equal to 1. Oh, that's curious. Commutative, that's nice. Note that for unit quaternion, Q is equal to this. That makes sense. Would it be 1 divided by... Oh no, it would be this. Okay, checks out. I think so. Yeah, okay, that makes sense, that makes sense. That makes sense. Honestly, I think, actually, I don't think I'll delve into all of this in the video. I think I will definitely link the paper down below. But I don't think I'll delve into all of this, because as fun as it would be to visualize, explain the idea behind it, this already explains it really well. I mean, this makes sense. Right here. You basically get as close to eliminating the, in quotes, sign as possible. Except you don't multiply it by the Q. Instead, this is kind of like, let's say that you have two real numbers, A and B. And if you want to get the, actually no, just one real number, A, right? If you want to get the sign of the number A, so A times A null, right, would give, oh, I'm sorry, it's A minus null powers. A null would give you the sign, at least that's the analogy I have in my head, I could be wrong here. Then A null would be equal to the opposite, like flip the sign of A and divide it by A squared in order to get like a fraction. So this on its own would bring it to 1. Like if you multiply it by a, then you get a 1. So this would bring a down to 1, but flipping the sign ensures that you get the sign back, it doesn't disappear in the square. Am I making any sense? Anyone watching, am I making any sense, or am I just... Or is it just an old man yelling at a cloud sort of thing? Am I just rambling? I don't know, I need a drink. There we go. Coffee, my beloved. But I do have to say, a sphere's worth is... It paints a picture, and at the same time, it's really funny, in my opinion. Non-zero Quaternions, we have... Okay. Makes sense. Q1, Q2, Q2, Q1. So... with colors. In the video, I'll have to do it with colors. Because it's really difficult to keep track without colors. Q1, Q2. Q1 times Q2. Inverse times inverse is equal to 1. Okay. And it completely flipped around is also equal to 1. But I'm guessing if we flip it in the middle, it will no longer be equal to... That's because... Oh, okay. No, this checks out here, because we have... Does it? Yes, it does. Because we have Q1, Q2... Q1, Q2... Inverse. This is equal to 1. And if we remove the brackets here, nothing changes. If we remove the brackets here, however, they need to be flipped. That's why it's 1, 2, 2, 1. Okay. I'm with you. We won't use the visibility, so we won't cover it here, except to say that we need to be very careful because non-commutative nature of quaternion multiplication. That's why I didn't want to divide it by both sides earlier on. That's why it was terrifying, because I knew it would have been off. We write an expression like this, we need to understand what that means. That's what it means. Oh, the inverse. That's lovely. Okay. I decided the video give a chemistry guide on how to make psychedelics so the colors make themselves. It's important because we cannot arbitrarily cancel. For example, observe that this has an order, which is not necessarily the same as Q2. In other words, Q1 don't cancel. Exactly. The non-commutativity is a slight issue, let's just call it. Alright, hi Mark, hi, welcome. Conjugation of a pure quaternion is pure. Great title, I really love it. Lastly, a fact that will be relevant when we discuss rotation using quaternions. If V is pure, and if Q belongs to H, then QVQ inverse is pure. Alright. Let's look more into this then, shall we? Theorem, we see that Q1, Q2 to H, we have real of Q1, Q2, be equal Q2, Q1. That makes sense because flipping them around don't really change the scalar part, right? That's a question. Genuine question. Okay. Brief summary. Here's a brief summary of properties for reference. This is great. I love this paper. It's amazing. Visualization of quaternions. Well, that'll be my job. The only quaternions we represent graphically are pure quaternions. Meaning, thank goodness. Meaning those of the form A, J, B, J, C, K. We represent these either as vectors or as points, depending on how we're using them. It's worth taking a moment to appreciate that when dealing with vectors V and W, that the quaternions product is this, captures both the dot product and the cross product in the vector part result. Imagine two vectors, V and W, when the dot product is 0 and the result is V cross is perpendicular to both. If we turn V and W a bit without changing the length, the resulting cross product shrinks, and the interpret that we've lost from the cross product, we've gained in the dot product, but as a scalar. Okay, that makes sense. As V and W get less perpendicular and more parallel, the cross product shrinks towards 0. I'm trying to picture it in my head. Dot product. When the cross product part vanishes and the dot product part is everything. Imagine them have gone to themselves, hated them. I'm thinking I'm gonna call the video even more complex numbers, because at the end I kind of want to do the bit where, like, basically I'm gonna go with rings for this. We're gonna start with good old-fashioned, then we're gonna go through, you know, I think it's, no wait, it's R, no wait, F. I don't remember. I think it was F. Quaternions are H because this is Q. That's idiotic. Oh, I don't like it. It's Z, Q, R. Actually, right here, all of these positive. Z, Q, R, R, C, H. That's how I'm gonna go. And then at the end I'm gonna do a bit where basically each explanation will take more and more time to explain. I can knock out positive integers in 10 seconds, right? But Quaternions obviously will take half an hour. But at the end I want to do a bit where I just end the video on like a cliffhanger with, and now let's talk about octonions. Just add more. First, so I can comment about my joke. If you do that, I can pin your comment if you want, Swim. I don't pin comments often, so... No, might as well. Why not? Actually, no. Wait, hold on. I can't pin your comments. No. There's a rule on YouTube that you can only pin comments from people who appear. No, sorry, Stream. I take it back. I can't pin your comment. There's a rule on YouTube that you can only pin comments from people who appear in the video. I don't make the rules. That's just how it is. That's why there was actually only one pin in all of my videos that I'm aware of.
Which is
Yeah, and you can already hear what video I'm talking about. The one and only. From the Flames video. That, unfortunately, I don't make the rules. That's the rule on YouTube. Still be trying to freeze with the other track and other pure Quaternion. Shift, fire, direction, yeah, okay, so rotation. Oh gosh, oh golly, how long is the rotation chapter? Yeah, I imagine so. Alrighty then. Okay. Give me a second, I need to. Can we take a break before doing this? Do something different? I don't know, work on the other video? I'm for that, you know? Maybe we could work on the data video. That would be neat. Can we do anything else? Can we do anything other than this? Hi, the Tefta! Hi, welcome! Hi, Tefta, how you doing? Alright, there we go, we have some more space. It turns out that extending complex numbers to Quaternions allows rotations to extend to 3 dimensions in a very convenient way. It permits us to easily construct a formula for rotations for an arbitrary axis. Good make it, how are you? I am losing my mind, currently. Undeniably and swiftly. Mostly because I am learning about Quaternions without... whilst at the same time trying to not get into linear algebra as much as possible, or group theory for that matter. First, a well-known formula. While this formula does the job, it is complicated from an algebraic point of view. Shocker! Meaning that it's fine for doing a simple calculation, but it's not the type of calculation we want to carry about. Okay, suppose u is a unit vector, and v is some vector. Then the result of rotating v around u by an angle theta counterclockwise with regard to the right-hand rule equals rotation v is equal to 1 minus cosine theta u times v u plus cosine theta v plus sine theta u cross, wait, no, that's dot, and that's cross v, okay. And then the proof. The nice thing about this is that in Blender, if we have an, I've mentioned it whenever I mention Quaternions, but it's a really nice thing. One of the main motivations for me making this video is that in Blender, you can rotate using Quaternions, which I think is rather nice. And also, yeah, okay, there we go. Proof. We begin by breaking V into components, one perpendicular to you and one parallel to you. Alright? Yeah. This makes sense, like if we have a vector, we just break it down like so, because it's addition. Okay. So far I'm with you. In order to rotate V, we leave the parallel, so we have another, this is our U, this is our V. We leave the parallel V alone, okay, and rotate the perpendicular V, and then add the parallel to rotated perpendicular, that is this. The reason for this illustrated in this picture. Okay, so we have couldn't help but notice that isn't perpendicular V arbitrary, or am I? I'm doing something equally boring at the moment too. What are you doing? Oh, unless the perpendicular doesn't matter, it could be arbitrary. Because of some quantum mechanics, you know, linear combination-ish tomfoolery afoot. Calculation, specific example in chapter 2, which would be rotation parallel cosine, rotation perpendicular is equal to cosine theta perpendicular plus sine theta u cross this. If we use this along with the fact that parallel u times v times u it's okay, no wait, that's not even this. It's dot, not times. Make it, get it together. Stabilizing UFO footage. That could be interesting. Just try every combination of words until it's explained. Drop a Library of Babel in there, and then just you find the answers. The proof is left to the reader. Verify this all makes sense. All right then, let's take a minute to verify that it all makes sense. I feel like if I visualize this, this could be doable. That would be my job in the video, wouldn't it? Visualizing this. I need a break. We're doing the other thing. I'm done. I'm done with this for now. That's it. I've reached my limit. We're doing the other thing. I will get back to it because of course I will. But for now, I need something different. We're doing the animation. I'm losing my mind. Explanation both makes sense and doesn't until the explanation makes sense. No, I mean, if I am confident if I visualize it properly, it will all make sense. I just need to visualize properly. For integers, you can think about the representation this way. We had the digits. For each digit represents 2 to the nth power. Okay, so right here, what we want is we want this to disappear. We don't care for it anymore. Render a single frame. My taskbar is broken on the other screen, as it too often tends to be. There, let's unhook the cookie clicker, the most important thing I have turned on here. Copy comment, you can't fool me, bot. Yeah, Mashrit, you are correct. How would we ever guess that Mark and Mark are the same person? Ah, Mark, you almost fooled us with your old account. You, for a second, ooh, I thought those were two completely unrelated people. Quadrillion, the quick click as Quaternion. Same here, actually. You know, I've just spent too much time on this so far. Okay. A really cool visualization will happen right here. But unfortunately, to get there, we still have a couple of things. So, for integers, you could think about our representation this way. We had the digits. Each digit represents a different 2 to the nth power. So what we want here is we want the number that we had, which we can copy from here. Here is a number. Now, we would like to move it, instead of moving it in an arbitrary way, we would like to move it to the center, which means bounding box, if I'm not mistaken. I think that could do the trick. I'm pretty certain. And then vector math, subtract. Wait, no, what am I doing? This should go here, I'm an idiot. Did I do it incorrectly? Oh, it's doing bounding boxes separately, is it now? It is. That's great. Yeah, not what I want. Realize. Okay, that's kind of more like it. Bounding box. Neat. I am brute forcing maths here because I'm tired. We want to take the center point of this, which is we have the end, the minimum, the maximum, correct? How do I do it backwards? Make a video about how to use Blender. I already made 2 of those, Swim, and no one cares about them. The fact you don't know is the proof that no one cares about those videos. Obviously, I'm doing this incorrectly. Okay, instead of brute forcing, let's actually think for once. Yeah, I'm pretty certain that's minimum, that's maximum. We care mostly about distance on X right now, which means we can just separate X, Y, Z to make it a bit easier for ourselves. And X minimum, X maximum, we want to move it so that the center point will be right here. Center point is as halfway, which means math, subtract, divide by 2. Subtract from the maximum the minimum, then we want to divide it by 2. That gives us the center point, and then we want to move center point to the right this much, combine X, Y, Z and plug it into X. I said off center. Good night, Swim. Wait, what? Why is it? You can have as many YouTube channels as you want on a single account. That is true. That is true. No one cares because they don't have Blender through in the title. Well, yeah, because I mean, geometry nodes in Blender are the easier part. In those videos, I'm mostly concerned with like explaining the mathematics for how to do stuff. So, for example, in the ball of spheres video, you know, the one with with the electron distribution. I could have done it by just distributing points on a sphere, but I specifically did it with mathematics instead to explain like the more general way to do it, the better way to do it with mathematics. Minimum minus maximum. Wait, maximum minus the minimum. What am I doing wrong here? Gee, is my brain fried after learning about quaternions for just an hour? I love the new video, thanks for including me. I hope you don't mind the way I included you, Tefta. That was the bit I had in mind. I know if you pictured it the same way. I hope I didn't misrepresent. I just thought it was funny. With, like, you know... I really hope you liked it. Because I did rush through it and I didn't actually re-ask for your confirmation, which I'm really sorry for. So I hope you liked it. I like it. I look a bit like a jag, but I am in real life. Well, actually, it's not that you look like a jag. It's just that I think it's that, you know, I feel like it really shows just how simple the controller is. I put in the title. I specifically put in the title that, you know, it's a simple controller, because it really was. It's, for goodness sake, it was a joystick with an 8x8, and I think that just illustrates that point really well. I also linked the video, the one I really liked, where I felt like I was clickbaited. I linked that right as you appear. Use was awesome though. I love that example. I've never tried to do what you did actually. The maths is the one thing I know, so had to stick to it. Actually, now I'm gonna be working on another project. Another practical project, which I also will have to work on after the stream. Start planning. That'll be exciting. Am I an idiot? I must be. This is the minimum, this is the maximum, correct? So if we move it, for example, by the minimum, it moves to the left. Maximum moves up? Oh yeah, right. So it should move by this. Yeah, maximum is here. Make it builds a weapon. No, we won't do make it builds a weapon just yet. It's too expensive. The whole circle thing I would not be able to do. The reason why I thought of it was because, like, on the very beginning of the video, I made the Blender animations to visualize this. And the nice thing there is the way I make most of my animations, as you can clearly see, is using maths. So I am good at describing things. One skill I carried over. I need to use it everywhere now, because the one skill I have. Am I mad? What is wrong with me? How can I not figure this out? What we need is we want the center point, which we can get easily, because that's just math, vector math. Vector math. Not mix. Make it need help. No, I need my brain to start functioning. I feel like more coffee. My goodness, this is so simple and easy. Why am I struggling with this? This gives us the center point of a rectangle. To move it, we then divide it by 2. Minus 2? No. Yeah, no, 2. I am indeed. Translation. Oh, translation. We don't want translation, do we? I don't think we want translation. Is that the issue? That wouldn't make any sense, would it? There we go. Now this gives us the halfway point. And now all we want to do is take the halfway point back, multiply by -2. Odd. There, I don't know, that's, my brain just didn't function for some reason. That's worrying. I also sold 2 last because of my vid. Hell yeah! That's great! Oh, that's great! I'm hoping, by the way, that's... Well, I mean, to be fair, my video really underperformed, so probably not that many people have seen it. But I'm hoping that some people went to check your channel after it. Alright. There we go. Now let's check the script. By the way, oh, another thing. I finally started using Python in Blender. I finally started doing it. And I've already finished one animation with Python in Blender. It's this one. Where basically, right here, I'm basically using like a... Let's call it a peculiar way to visualize numbers. So basically, I'm trying to showcase here that any kind of binary system is completely arbitrary. And the 3 examples I use for a way to save data using binary would be the typical way to save integers, or a way in which each next integer saves an even number, or a way in which each integer represents a different prime number. And this is fun. This is really fun. Because each of those really are prime numbers. And the way I've done it actually is, if we go to geometry nodes, you can see that right here, this just takes in a value and represents it as a, just, you know, it takes the value, turns into a string. But right here, each of these keyframes is a different prime number. Because I actually did a script which just replaces all the keyframes with a prime. And this is good. I'm finally starting to use Python in my animations, which is great. It's gonna make the whole process so much easier. Alright. Integers is gonna be written this way. We had digits. Each digit represents a different number at the nth power, meaning that for a number like 100, for example, okay, so what we want now is 70, yeah. This. And I think just sideways LaTeX with 2 to the nth power. So basically, times 2 to the 0th power, I think. Which could be good. There's gonna be a lot more that came from. 1, 2, 3, 4, 5, 6, 7. Each of them have a different material because I didn't set the default because I'm an idiot. But I mean, hey, happens. They can all be a tad bit off because I just simply don't care about these irrelevant details. Now, rotate -90 and... Don't mind me playing cookie clicker in the background. I'm being productive, okay? In my defense. I think this visualizes the point pretty well, doesn't it? Non 3D slicing tool using Python. That's impressive. They're a bit off, but I don't care. There we go. For each digit representative, meaning that for a number like 100, for example, which means right here we want to do an animation. Thank goodness. 6 to 5, because why not? And let's do 0 to, well, I mean, technically for a full 100, but we don't care about that, so it's fine. Another thing I could do is do pluses. 1, 2, 3, 4, 5, 6, 7, like this. They are a bit too big, which I don't fully like. They should look good. Proper solid. Proper rock solid. Back to the importance business. Oh. We did a fair good job already with the Quaternions. Learning about stuff like this always tires me out for some reason. But there we go. What's next in the script then? 0 times 1 plus 0 times 2. Oh, right here I'll just have to render each frame separately. 0 times 1 plus 0 times 2 plus 0 times 4 plus 0 times x plus 0 plus 16 plus 1 times 2 plus 1 times, yeah. That's 100. $35 Quaternion cookies. You know what? Even with coffee, I'm pretty tired after the Quaternion stuff. We will continue with it tomorrow, but now I have to go. There's more videos to be done. Unfortunately, we didn't get to the simulating part, but tomorrow we should. So I'm unfortunately gonna go, work on the videos, so on. And for now, I suppose that'll be it. Thank you everyone so much for watching, and have a great day. Bye.